This video is the second video on similar figures. So for worked example 12, which is above this line, it wants us to prove that the triangle ABC, so in other words this green triangle here, it wants us to prove that it's similar to DEC. The first video on similar triangles looked at with us the similarity tests. So AAA, SSS, SAS, RHS. So we can discount RHS because it's not a right angle triangle. We can discount the ones that talk about the sides because we don't have any measurements for sides. So we're going to prove this, I reckon, using the AAA test. This line D to E is parallel to this line A to B. And with parallel lines, this angle here, angle B, is alternate with this angle D, and alternate angles are equal. Because DE and AB are parallel, we can also say that angle A here and angle E here are alternate angles, hence they're equal. We're also able to say, due to a couple of reasons, that this angle here and this angle here is equal. We can either say that because we know the three angles in a triangle add up to 180, and if these, the dot and the star angles are equal, then the third angle in each must be the same because the triangles add up to 180. The other way that we know is the two angles I have indicated with a tick. They're called vertically opposite angles. So we've just shown that angle B is equal to angle D, alternate angles. We've said that angle A is equal to angle E, also alternate angles. And we've said that angle C is equal to angle C in both because they are vertically opposite angles. So we can conclude all three angles are equal. Therefore, the congruency test we use is AAA to prove that the triangles are similar. Let's look at the next worked example. Okay, in the next worked example, we've got a 1.5 metre pole, which is here, casts a 3 metre shadow down here. Find the height of the building, this height here, if it casts a 15 metre shadow. It's wanting to know if these triangles, we use our knowledge of similar triangles. So I'm going to draw out the two triangles. I'm going to call this B, A, C, and this E, and this D. So I've got a triangle, A, B, C. I'm trying to work out this height here. I know this is 15, and that angle is there, that angle is there. Draw my second triangle, my E, D, C, so that angle's the same. That's 3, that's 1.5. So using my knowledge of similar figures, I can work out H. This is how I do it. Okay, firstly they are similar triangles because this is a right angle in both of them. So these angles must also be equal because the three angles in a triangle add up to 180, and they've both got 90 and they've both got dot, if you like, so the cross must be the same in the both. So they are similar figures, and if they are similar figures, the sides must be in the same scale factor. So the H over 1.5 is equal to 15 over 3. Because these are the corresponding sides to each other, and H to 1.5. So I'm going to times both sides by 1.5 to tell me that H is equal to 15 times 1.5 divided by 3 is 7.5 metres. So the height of the building is 7.5. So how I found that out is using my knowledge of similar triangles. So the triangles are similar because the AAA rule, all three angles are equal. And so then if the angles are similar, the corresponding sides, I guess the wording from the thing, the corresponding sides are in the same ratio. So because we know they're in the same ratio, we can express it like this, which helps us then work out H.